How's it going, guys? Afternoon, guys. Thanks for jumping on stream. Look at this MTX today. Oh wait, which camera isn't working? Let's get that up and running. There we go. Nice old MTX Thunder. Yeah, looks like it, doesn't it? So I need to check the bit of paper that came with this amplifier, because he explained what the issue was. He says, hello Steve, how's it going, John? All of you guys, thanks for jumping on. So we have MTX, all channels play when the front RCA is plugged in. The rear settings don't work. When the rear RCA is plugged in, there's no sound. So this is what my guy is saying about this. There's also a JL audio that I've got to fix from this guy as well. So all channels play when the front RCA is plugged in. Okay. But when the rear is plugged in, nothing works. That sounds like a setting. So these amps have some switches on the preamp section here. I'm pretty sure you can tell it that you only want to plug in the front RCAs. So you see, yeah, there's a switch here that says 2-channel or 4-channel. So I suspect when the 2-channel button is pushed in, only the front RCAs are going to do anything, and the rear RCAs won't do anything. But the guy does say that the rear settings aren't working, even when we have that probably pressed in. So we're just going to go ahead and confirm that we have the issue that's being described. Turn the gains down and stuff. So we're going to have the crossover off to start with, rear channel gain down, crossover off to start with, high pass, low pass, so that's off anyway, so it doesn't matter. Prism effects, keep it on. Yep, that's fine. Mono out, keep that off. High pass filter, frequency off. And input sensitivity times 1. Okay. Let's plug us into our front RCAs here. So we've got front, left and right going in. Let's see if we've got any audio output. Let's plug some power wires in. Power wires. How's it going, guys? Hey, Ian's finally caught me on stream. How's it going, buddy? It's been a while since I've seen your name pop up in the live chat. Good to see you, good to see you. I used to stream mostly in the evening times, but these days I'm streaming mostly in the afternoons here in the UK. So I think I'll probably get a slightly different audience to what I used to get when I was streaming in the evenings before. Good afternoon from South Africa. How's it going, Tiger Electronics? Thanks for jumping on. Jordan says, I have the 1500 watt mono version of this amp. I've had for years needing repair. I gave up on it about 10 years ago. Yeah man, jump back on it. I'm sure you can get it sorted. These use the increasingly frustrating American size Allen keys, so I don't seem to have one that fits. Use one of these star security bolts, security bolt drivers here. There we go. Right, so the guy's saying that the rears aren't really working when you have the rear plugged in. So let's just confirm we have front output. So we've got it on 4-channel mode at the moment, so we need to have audio output on front, left and right, obviously, to start with. Okay, we should probably turn the gain up a little bit. the gain potentiometer is very noisy as you move it. It also smells very hot. You know what I mean? Thank you very much. Oh, that's the perfect mug as well. check out the mug. It's an op-amp joke mug. Ooh, that's hot. Yeah, it doesn't smell so good. So at idle here, we're drawing 3. What is it? So as soon as the output section clicks in, we're drawing 3.2 amps, which is not excessively high. Does smell a bit funky, but anyway, let's just continue probing this, because the guy's had this amp powered up for hours and hours before. So we've got output on the front left. Let's check output on front right. We have output on front right. I just noticed actually the smell only came when the fans turned on, so I suspect it's just dust, like, yeah, coming out here. So we've got output on front left and front right. That's cool. Okay, so there's no output on the rear yet. Okay, so if we switch this button on here, which is going to turn this into a two-channel input mode amplifier, then we should get output on the rears. Ah, we don't. There's no output on the rears, even with the amplifier switched into two-channel mode. Okay. Thanks for the €2, Ian. Thank you very much, buddy. So there's a little bit of DC on the rear right. Got 1.7 volts worth of DC on the rear right. There's no DC anywhere else. So yeah, that's a bit interesting. That suggests there may be an output section fault or something there. 1.5 volts DC on the rear right. Okay, let's plug the RCAs into the rear inputs now, into rear right. See what happens. Do we get anything coming through? Whoa, a huge bump to DC. When we turn the crossover on and off, massive spike coming through the preamplifier circuit there. Let's see if that's the same with the front channel. No, so you see how the front channel, we can turn the crossover on and off and there's no massive DC spike. Well, there's a massive DC spike when we do it with the rear channel, and also with the crossover on, we have about 4 volts of DC there on the speaker terminal. So I reckon this is absolutely a crossover, a preamplifier fault here. Probably a dead op amp or something in the rear channel. Not getting any signal through at all from the rear channel. Low pass, low pass, low pass, high pass, etc. Yeah. Okay. Cool, so our issues is slightly different to what the guy has stated here. He said that all channels play when the front RCA is plugged in, but that's actually not the case. We haven't got any output from the rear just yet, and I suspect it is a preamplifier fault. So let's get this case opened up and have a look at what's going on with this preamplifier board. Ken says get some merch. Right, let's have a look at some live chat real quick. Ah, man, I've thought about doing merch for ages, but I'm a tiny channel. I'm a very small YouTube channel. I don't really know if I would be able to do merch and if it would really be successful or profitable, or, you know, I might sell, I don't know, 10 items of merch to some of you dedicated repair fans. I could probably do some boom or bust merch. I think maybe when boom or bust really takes off, like, I'm hoping that at some point boom or bust reaches the level of viewership that the likes of Derek gets on his amp dyno videos. So obviously the kind of people that are watching amp dyno videos are obviously into car audio, into tech, into learning about the equipment. So I'm thinking that that audience that watches the amp dyno videos probably would be interested in Boom or Bust as well, because it's a similar kind of area. It's a experimentation, finding out about different enclosures and stuff like that. So I'm hoping that at some point in its future, Boom or Bust gathers the viewership or exceeds the viewership of the likes of the amp dyno videos, or just other stuff like, you know, EXO gets like hundreds of thousands of views. Obviously that's real world car audio, and following builds and stuff is very exciting. But I think Boom or Bust might be able to get there, especially in future seasons when we make it be even cooler. So maybe I'll do merch then. Bevid's cap, please. What would it have on it? Sam, Brew, you are so busy, but please see the 2 links I sent you through the amplifier repair service. I know it's for subs, but I'd like to know your opinion, please. What links was that? I can't remember. Was that on eBay? I did actually have a look, actually. I watched the video. If this is you, if you sent me a video of I think it was a DB audio, I think it was a subwoofer with a spider that was disconnected. I actually watched the video, I just hadn't got around to replying yet. But yeah, it definitely would be repairable, but the cost to repair it might not be worth it. I don't know what those subs kind of sell for on the second-hand market, like fully functional, but that kind of repair would take some time. You'd have to strip, I'd have to strip the entire soft parts out of the woofer, which I can do, make a repair to the triple joint, and then realign it all back into the basket and motor. So yeah, it's definitely doable. It's just time consuming, and it will probably cost about the same as what a working woofer would cost, so it's a bit of a difficult one really. Right, yeah, let's get this thing apart then, shall we? Now these MTX amplifiers, we have, now the top assembly should come off completely separately. So I'm thinking it's going to be 1, 2, 3, 4 for the top assembly. These 4 bolts are probably going to be for the heatsink, which is a really cool heatsink design in the middle of the PCB. So I think we should be able to get the top piece off just by these bolts here. I'm glad you guys are really enjoying Boom or Bust, man. Have you ever wrapped a voice coil? No, although the idea has crossed my mind to possibly start researching what tools and equipment I would need to start making my own custom voice coils and stuff like that. That'd be really cool. I don't know how much of a market there really is for it though, but Can anyone think of some funny Bearvids or amplifier repair related stuff that you could have on a mug? How about this, right? A mug that is, you can get mugs that are temperature sensitive, like so the design changes when the mug gets hot, when you pour a hot drink in it. How about we have like, I don't know, like some MOSFETs on the mug or something, and then when you fill it up, they all like explode, like it looks like they're on fire. That'd be funny, wouldn't it? Anyone think of some really funny puns or really cool things to have on a mug that's like amp repair related, or it's about the box, man. Only OGs will remember that. We'll get that reference. Air freshener that smells like burnt voice coil. Okay, so the preamplifier board is actually in the top assembly here. So our issue is either on the top assembly, or it is on the board after it comes from the top assembly. I'm going to go ahead and assume that the issue is most likely on this preamplifier board here. And one of the ways that we can see if that's the case would be to power the amplifier up now with the preamplifier circuit completely disconnected, and see whether we still have DC offset on the rear right, because if we do, then it's possibly not the preamplifier board. But if we don't, then it probably is a preamplifier board. So let's power up. Oh, we have much less current draw as well. Does anyone see that? We have 2.1 amps worth of idle current draw, and there's no DC offset on rear right anymore. We had, what was it, 3 amps of idle current draw with the preamplifier board connected? Yeah, I think there's some op amp has gone dead short or something on this preamp board, because that is a huge difference in idle current from just not having the preamp board connected, which is supposed to be extremely low current devices. So I think we might see some burnt component on here. Let's find out. Let's take the screws off of this. BPS Car Audio, how's it going, buddy? Jordan says, I have a semi-successful voice coil I made from a soda can. I use a secondary wire from a microwave oven transformer. It's in a Type R12. Damn, and it actually plays. That's freaking awesome. I love that. I love hearing stories like that where you salvaged some stuff and made it work. What do you mean semi-successful? So what's wrong with it? Does it rub on the motor perhaps? Oh, it seems to make this up very sensitive to low frequency. So it prefers the lows and doesn't really sound great on the higher stuff, do you mean? Right, here we go. Here's our preamplifier board then. Let's get it on the camera and have a look, shall we? Just need to disconnect this wire for the LED lights. Okay. So, here we go then. Here's our preamp board. So we saw a huge reduction in idle current by having this disconnected. I'm just going to confirm that that's actually the case. If I plug this back in, okay, plug it back in. Now let's power the amplifier up and keep an eye on the current draw. Oh no, it's gone down, 2.6 amps. I'm sure it was up at 3 point something a moment ago. Okay, and if we remove it, okay, well it's still 0.5 of an amp different, which is quite considerable, but it's more within spec than like over an amp that I was thinking was an issue. Okay, well now that we've got the preamp board off, let's say take a visual inspection here. Actually, looking at it with my eyes, I can quite clearly see a visual difference between some of these components on here. Let's just give you a good view of this. Okay, so let's zoom right in. So, just from looking at this, okay, can anybody see anything that looks a bit suspect? So if you're thinking this op amp, then yeah, me too. All the others have nice shiny legs. This one has far more matte colour legs, and it looks a bit kind of darkened around the op amp here. We've also got a couple of resistors here, namely this one and this one, which are blackened and burnt. So I suspect this op amp has failed, gone dead short, and has also killed the resistors, which are probably low value resistors. Yeah, this looks like what used to be a 10 ohm. That looks like it might have been a 10 ohm. They're probably in line with the VCC supply for this chip, and they've been burnt due to the excessive current draw between those two. So I think that we need to, without even looking any further, I suspect we just need to go ahead, pull this op amp straight off the board, and drop a new one in, replace these two resistors, and just see what happens from there. So I don't think we're going to bother doing any more testing, because it's quite obvious that this is our problem here. It's not always obvious from just looking at electronics to find the issue. Like so many times electronic components don't actually show any visual signs of being damaged or failing, but in this case just the heat has given it away. So yeah, I suspect it's this chip and then the two 10 ohm resistors that are in probably in line with the VCC. Should we have a look? Should we just, while my hot air gun's heating up, should we just see if these resistors are actually the ones in line with the supply? Yep, there we go. There's our supply for one side. There's our supply for the other side. So yep, that was it. Just 10 ohm resistors in line with VCC plus minus. The reason I asked about voice coil is because I have a Rockford T115. I think my voice coil is messed up because only that sub keeps killing my amps. Killed my BD1000 twice. Changed sub, no issue. So either the sub is actually faulty, but you should be able to check that by reading the resistance of the voice coils and seeing if they're still within spec. But it could just be that that subwoofer, in how you were using it, has a lower impedance rise than maybe a new subwoofer. I don't know what you replaced it with, but if it was a smaller sub or a more efficient sub, or you got it in a bigger box than you had this Rockford T1 in, could be that the new sub doesn't put as much strain on the amplifier as your old Rockford used to. If your vehicle's power supply is particularly weak and wasn't able to actually drive current into the Rockford sub, that could cause the amplifier to fail, whereas with the new sub the demand is less, therefore it's not an issue. Did that and it plays fine, but the amp gets hot. So what was the resistance of the coils? I assume the coils were reading fine, but if the amp gets hot, then yeah, it definitely suggests that there might be an issue with the sub. Usually it will actually present you with a lower resistance. You know, the voice coil will be like not what it used to be. If it's a dual 2 ohm, one of the coils might be reading 0.8 or something. But if it's not, then you know, if it's not reading a low resistance there, it's unlikely that the coil will suddenly jump to a lower resistance when you start playing it, but maybe. Ken says less than 1 ohm. Well, what's the subwoofer's coil spec supposed to be? Is it supposed to be... Wait, what do you mean each channel? So each voice coil was less than 1 ohm. What's it supposed to be? Is it supposed to be a dual 2, dual 4? Right, let's get this stanky, crusty op amp out of here, shall we? Supposed to be dual 2. So if your subwoofer is supposed to be dual 2, then each coil should read no less than 1.4 ohms each side, because remember you're reading DCR. So provided each coil is reading the same and it's above 1.4 ohms, the subwoofer is probably fine. If it's reading less than 1 ohms, then yeah, the sub is absolutely toasted, and I'm surprised that you would continue to try using it. Okay, op amp removed, and the two 10 ohm resistors, one there, and one there. Well, that's half of that one. There we go. I'm just having a quick look because I assume that these were 10 ohm jobbies. They're quite hard to read because they got burnt, but this definitely says 10R0. Yeah, they're 10 ohms. Yeah. I didn't even know my Rockford amp had a fan until this issue. Jokes. Is it more likely for an amp channel to fail and kill a driver, or the other way around? So the most likely thing is for the driver to fail and kill the amp. The reason that it's unlikely for an amp to fail and kill the driver is because most amplifiers will have DC offset protection. So the only way that an amplifier failing is going to kill a driver is by the output transistors or MOSFETs shorting, therefore sending the full DC rail voltage to the driver voice coil, which is catastrophic, and the coil will die in like a matter of seconds. But that doesn't usually actually happen because amplifiers they detect the DC on the speaker terminal and shut off like very quickly. So the only time it will happen is if the amplifier is a really terribly designed amplifier, just literally a throwaway piece of junk amplifier just designed to sell and make profit on then and there. If the amplifier has no DC offset protection, then that would cause the driver to fail if the amplifier failed. But yeah, literally any amplifier with any decent reputation will have DC offset protection, so that won't happen. Okay, so let's see. I think I've got some brand new 074s. Pretty common part, I should have. Got some TL494s. Got some 074Cs. There we go. That would do. Now, I'm not actually going to use the hot air to solder this to the board. Reason being is that op amps typically are, or seem to be, very, very sensitive to heat. So I'm actually going to solder them manually with the iron. Cool, that should be pretty much done. A little bit of extra solder on a couple of these pins that look like they might need it. There we go. Clean that up. Now I just need a couple of 10 ohm resistors. Blah, 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 blah. J Wolf, the amp turned on still but went into protect. I've fixed it now but was running as one channel was dead and so was the driver. Sounds like the driver died first, I would suspect. Depends what amplifier it is, but yeah, Ken, your Rockford subwoofer is broken. Stop using it. Don't use it on any amplifier. If each voice coil is supposed to be 2 ohm and it's reading less than 1 ohm, then it's broken. Stop using it. My Sundown SAZ 4500 died when my batteries died. Oh no. That's sad. Might have just been a power supply section failure. Yeah, I think the those Sundown amplifiers use 3205s, TO220 package parts in the power supply. They're not too expensive, well they weren't too expensive a couple of years ago, they might be now, everything is more expensive now. But you don't actually have to use 3205s if you don't want to in that. If you want to save some money, you can use some 65 NF06 or something like that, and it will still be fine. You can get away with using some slightly lower powered MOSFETs in those kind of amps that use the 3205s. Obviously not ideal, but if it's your own amplifier and you're wanting to repair it on a budget, then yeah, you can get away with using some slightly lower powered MOSFETs in it and it should be fine. I think that the amount of 3205s that amplifier uses is a little bit overkill. The reason I say that is because the B2 Riot 7500 V2, so this is a 7500 watt RMS amplifier from B2 Audio, the V2, the newer one, actually uses IRF 3205s in the power supply, and it only uses, I think it's something ridiculous like 16 of them for 7.5K, and the Sundown 4500, I'm pretty sure, uses something like 28 of them for 4.5K, so it's using twice the number of FETs for half the power. So you could definitely get away with using some slightly lower powered, cheaper FETs if you wanted to, and it would be absolutely fine. Okay, so that's the op amp and the 2 resistors replaced. Let's see whether that has allowed the rear channels to come back to life or whether there might be some more issues in this area that we need to address. Yeah, I don't see any other visibly burned resistors, so that's a good sign. So yeah, just going to go ahead and call it off a bit. Love the car amplifier repair. Thanks, Colin. Appreciate your five US bucks, man. Thank you very much. That's very kind of you. I'm glad you're enjoying the amp repairs. Do you know much about the brand Precision Audio X3000? I haven't heard of that brand, however I doubt they're making their own circuit design, so I suspect it's a generic circuit. Let's have a quick look on the old Google machine and see what comes up for that circuit, if there is any guts. Oh wait, hang on, this is a home receiver? Precision Audio X3000. No, I'm not actually getting any results for that, buddy. Can you clarify the brand and model? Yeah, anyway, so let's plug this back in and see whether we've got life on our rear channels now. Let's just pop that down there for a minute. So the first thing we're looking to see is that we don't have any DC offset on the rear right channel anymore. Next thing we're looking to see is that we don't have the excessive current draw from the power supply anymore. And then we'll look for some nice smooth sine waves on the rear channel. I'm going to plug the RCAs into rear right here just to see. And yeah, let's hit it and find out what we got. Hey, there we go. Nice clean sine wave on rear right. And let's check rear left. Nice clean sine wave on rear left. Oh, no, not a nice clean sine wave on rear left. Almost. Almost there, but not quite. Okay, yes, definitely a problem there with rear left. Now, is that preamp or is that drive circuit for the? Because this could be a completely separate issue. Okay, let's go through the preamplifier controls again and see whether that affects this waveform shape at all. So we're not generating the top half of the sine wave here above a certain level. That could be a lack of VCC on one of the op amps. But let's see whether changing any of these settings. So we're going to go from 4-channel mode to 2-channel mode now. So if I use the front input, whoa, heck no. Oh my god, that's even, what is, wow. Okay, it's definitely a preamplifier fault then, I think. What is that? It's freaking Batman. This is Batman mod. So plugging the RCA into the front left input and selecting the, oh heck. Selecting the button for 4-channel mode causes this. Wow, what the heck? Okay. And it also seems that the gain for the front channel is affecting the rear channel as well. Seems like the front channel is affecting the rear channel. But only on the left speaker. Yeah, okay, so if we plug the RCA into front right, okay, we get nice sine wave on front right, yeah, as we should. On rear right, we don't have anything, naturally, until we press the the 2-channel button. That's behaving exactly as expected. Okay, cool. However, on the left-hand side, we have a nice clean sine wave on the front left, obviously, as expected. But on the rear left, we get this nonsense. And actually, the current draw goes through the roof. Watch the current draw as I put this RC in. We're idling at 2.2 amps. As soon as I put that in, all of a sudden a whole extra amp is drawn. And interestingly, you can't really see this because of how the amp is situated. But if we take a look at the preamplifier board here, the LEDs on the preamp board actually shift. look at the LEDs on the preamp board. They like change colour as I introduce the RCA. Wow, yeah, something's very, very not happy about that. Okay. So, more issues on the preamp board then, perhaps. Okay, let's try enabling and disabling the crossover and see if that causes anything to... Right. Okay, that current only happens when I increase the gain above a certain point. So, that current draw only happens when I start clipping the amplifier here. Right. So let's just enable and disable the crossovers here. As I enable and disable the crossovers, the colour of the LED changes, and so does the sine wave output. Okay. We shouldn't have a sine wave there right now because that's in 4-channel mode, so we shouldn't have that. It's something to do with this crossover. I think it's the crossover op amp. That could be dead as well on this side. That changes the shape as well, whatever one that is. What's that button for? That button is rear channel crossover on off, high pass versus low pass. Ah, interesting. The current draw goes up considerably when I enable that high pass, low pass button. Okay. Rare. Okay, what about these bottom controls? Got high pass, low pass frequency, mono out on off, input sensitivity. What about if we change the input sensitivity? Does that do anything? Whoa, input sensitivity goes through the roof. Oh, something just smoked as well. Okay, right, let's take a look at this then. So we got some smoke come from this PCB just now, and that seems to come from the 10 ohm resistor that we just replaced. So there's still issues going on over here with this op amp stuff over here. So what I just noticed, what just happened was I pressed this button in, and this button is the input sensitivity button, and pushing it in goes to ×1 and taking it out goes to ×10. So I pushed it in, which increased the sensitivity by 10-fold. Now I don't have like that much signal going in. I've only got 1.7 volts peak to peak, not even RMS. I've got 1.7 volts going in. Let me just show you exactly how much input voltage I've got going into the amplifier right now. I've got 300 millivolts on the RCAs, okay? So that's not an issue. That shouldn't have caused that to fail. So something funky is definitely going on over here with part of this circuit. So what I'm going to do is I'm going to remove the 074 that I just fitted, because I don't trust that now. Something happened there, I don't trust that anymore. So we're going to remove the 074 that we just fitted, and I'm going to replace the 10 ohm resistor, or probably the two 10 ohm resistors that we just replaced as well. So I'm going to remove both of those completely and power the board up, and I'm going to look with the oscilloscope on the preamplifier circuit for any leaking DC to any of the other op amps around here. Was the smoke viewable on the stream? I wasn't sure whether you could actually see it, but it looked kind of cool in person. Okay, so don't trust that anymore. I don't trust these two 10 ohm resistors either. They look a little bit blackened now. Okay, so with those removed, I'm going to plug it back in and have a look and see whether there's any DC leaking anywhere around the board to these pads here. So power on. Now with that op amp removed, I probably should not have any more sine wave on the rear side. So let's just check to see what the amplifier does with those parts removed. Curious to see. Okay, so with those parts removed, we have all kinds of weird sine waves going on the rear channel. Both rear left and right have weird sine waves on them. If I remove the RCA, they go away. It's only when the front left is plugged in. So if I plug in the front right, nothing weird happens. It's only with so it's something to do with the front left. When I plug in front left, all kinds of weirdness occurs. Specifically when the front left ground is inserted. Okay. Right, let's have a probe on here then. Let's see what's going on. We're going to use the thermal imaging camera. Just see if any of the other components on this preamplifier board are getting hot at all. So the whole board is quite warm, probably because we've been soldering. But I don't see any specific hot spots, I don't think. Let's use some isopropyl alcohol real quick just to cool it down. Okay, so it's cooled down a bit. Now let's power it back up and see if there's any like obvious instant hotspots. So we've got two op amps heating up a little bit there. Got the transistors heating up there as to be expected. Yeah, nothing is really getting very, very hot that's a cause for concern. Okay, let's have a play around and look for some DC where it shouldn't be or anything weird going on. So I'm going to probe the pins of the op amp that we just removed, the 074. Now that should only have DC on the VCC input pins, which I think are 4 and hang on a minute. What is it? 1, 2, 3, 4, 5, 6, 5, 6, 7, 8, 9. Probably 4 and 11 or something like that. They're opposite each other. We should only have DC on the VCC pins. There should be no DC anywhere else. So let's power up and have a look. So amp's powered up. So actually, we're not going to get any VCC on there because it's on the it's on these resistors that we've removed. So we've got plus 15, yep, and minus 14. That's fine. Check all of the other pins here. So there should essentially be nothing. Okay, there's 4.5 volts on this pin. Interesting. Don't think that should really be there. Because why would there be DC? There's another 3.2 volts there. Okay, so we've got a bit of DC over here. I'm not sure that should be there. Let's check the other op amps and see what we've got going on those. So these are preamplifier op amps. There should only be DC on the VCC pins. Oh, that's weird. This I think there's some solder flux or something on this one from when it was installed in the factory that's conductive, because it's kind of giving me bit bumps of DC when I touch on the case here. All right, not getting any DC on any of these. That's cool. Okay. Yeah, looks okay. Got our VCC on that one. That's fine. Okay, that one looks good. How about this one up here? Uh-oh. Okay, so we've got 2.7 volts DC on that one. 2.7 on there as well. Another 2.7. There's our VCC. 1.0. 1.5. Oh, heck. Negative 13. Okay, that one is suspect. This one is suspect as well. Yeah, negative negative 5. Yeah, okay, that one is suspect. Let's go ahead and pull that one off the board as well. Don't like the look of that. If anyone thinks there's something missing, there's a diode pad here labelled D600 that isn't actually mounted to the board. That's deliberate from factory. You can tell that that's never been, that's not been fallen off or anything like that. There's also a resistor here. Lots of the times you'll find with circuits, you'll find that there are component pads that aren't actually populated. That's pretty standard. And the reason for that could be that this PCB is shared between different models of amplifier, and the components are just fitted depending on what model it's being used for, or it was just a component that wasn't deemed necessary or that was causing issues or whatever, was just taken out. Okay, so that's removed. I'm gonna sneeze now. Oh, come on. Do you ever have that where like there's a sneeze coming for like a good 5 minutes, and then you give in, you're like, right, I'm gonna do it, I will let you out, and then you go to let it out and it's like, actually nah. It's a bit like when a cat is like at the door like this. Cat's like scratching the door like wants to get out, and you're like, alright, open the door, let the cat out, and the cat just sits there like, you're like, fucking God, that's what it's like just now. Alright. So that's that removed. Let's hopefully that DC has disappeared from there. Okay, the DC has disappeared, but we've got some weird kind of waveforms on here now. What the heck? Yep, that's interesting. So DC is, we've got 2.7 volts on that pin. 1.0, so a lot of the DC is still there. We've got this weird waveform. Appears to be coming through this transistor, this diode here, D603. Okay, could just be because there's nothing mounted. So sometimes if you've got a pad that's just floating with no component mounted to it, it kind of acts a bit like an antenna, could be picking up some noise from somewhere. Yeah, 2.5 volts still on there. So we've got some DC is definitely still present on these pads, but some of it's missing, like that negative 13 is no longer there. So let's check the op amp over here. Maybe this one's bad as well. Oh, hell no! Negative 9 volts on that pin. That doesn't seem right. Although it could be, because one of these op amps could be responsible for the LEDs. Oh, hang on a minute. Yeah, the LEDs on this board are no longer actually lighting up. So this op amp that we removed might have been something to do with the LED color control, because that's now no longer functioning. So that's something I hadn't really considered, is that actually there might be some op amps over here that are responsible for the LED control, not just audio. There's still quite a lot of DC on this. Now we know that this op amp down here is responsible for audio, so there shouldn't be any DC on any of these pins, any of these pads, and there's 3.1 volts over here, so that's definitely not right. So even if this op amp over here is supposed to have some DC on it because it's to do with the LED control, this one's not supposed to. So we're still tracking down an issue here. Let's check this one over here. No, that's fine. That's VCC. Nope. Okay, this one has 11.7 volts on pin on the final. Oh, is it the final pin? 1, 2, 3, 4, 5, 6, 7, 8. Pin 8 has 11.52 volts on it. 3.7 volts. Okay, this one here has quite a bit of DC on it as well. Okay. I think what the sensible thing to do actually would be to just replace all the op amps on here, because that just rules everything out, doesn't it? Let's go ahead and replace all the op amps on here, because that just definitely rules out that any of these are bad. It also allows us to check the voltages with them all removed, so we can see where there's DC on the pads where it's supposed to be, rather than it being leaked through from a failing op amp. So let's remove that one. 072Cs are cheap enough. Like, this isn't really, you know, a big deal replacing all of them here, so. But having them all off of the board will actually be beneficial, and we can just run some tests. Yeah, so with them all off the board, let's power it up again and just see where we're supposed to have DC and where we're supposed to not have DC. Right, idle current draw is now down to 2 amps, so we've lost quite a lot of idle current draw. There's no LEDs lit at all now, they're completely off, not even dim at all. So, assuming that these 3 are supposed to be audio op amps, we do still have DC floating around on these. 2.7 volts. Now I'm wondering whether, what's going on with my, I feel very tickly at the moment for some reason. I'm wondering whether there might actually be a problem with the op amps down here by the RCA inputs. Excuse me. So I'm going to disconnect this board for a moment. Okay, disconnect the preamp board and just have a look down here, see what's going on, make sure there's no DC down there, because we know that the op amps down here are not going to be for any LED drive, LED colouring or anything like that. These are solely audio op amps. So no DC should be anywhere other than on the VCC input pins. So let's have a look. Okay, nothing so far on this one. No. No. VCC. No. 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 Okay, nothing on that one. VCC. Nothing on that one either. Ugh. So what I can do is I can try and inject a. Hang on a minute. I'm gonna have to go to the bathroom. Be back in a second. Wow, it's just like a wall of pollen hit me in the face or something then. So we have our audio input here. That seems fine. There's no DC on any of these op amps over here by the RC inputs. Now, the audio will be routed from this circuit over here to this header at the back to preamplifier board with all the RCA, you know, with all the crossover points on it and stuff like that. So if I inject some RCA signal with that preamp board removed, I should be able to see clean sine waves coming onto some of these pins over here. We should on this header really, we should probably only really have plus minus VCC for the op amps and LEDs and stuff like that. We should also have sine waves coming from this this header, and also sine waves going back into the header from the preamp board. So if this is a 4-channel amplifier, we should assume that we're going to have sine wave in, ground, in, ground, in, ground, in, ground, VCC, VCC, ground, ground, sine wave in, ground, yeah. So we should have 4 pins for sine wave in and their grounds, although really there should only be 1 ground, but whatever. VCC and its grounds, and 4 sine waves out. So let's have a look and see what we've got. Power it up. Okay, so this pin here, we bring the signal a little higher. Okay, so this is a nice clean sine wave coming from our RCA inputs. Cool, cool. This is left front. So left front, yep, nice clean sine wave. We've also got a sine wave on this one as well. So a sine wave on both of these. These pins could just be like together. It could just, you know, be 2 pins that share the same contacts. So 2 sine waves there for left front. Okay, cool, cool. That is our, oh, we've got 5 volts DC on there. Okay, so that could be a supply, 5 volts DC. Nothing on any of these ones. We've got 15 volts DC, negative 15 volts DC, that's our input supply. We've also got 5 volts DC on this one, and 12 volts DC on that one. So we've got a few supply voltages. Looks like we've got 2. We've got, actually, well, one pin here is 5.7 volts. One pin here is 5 volts exactly. So the one that's 5 volts exactly is going to be the 5 volt supply. This other one that's 5.7 volts, not sure what that would be for. So we'll just bear that one in mind. 5.7 seems a bit of a random number, but we're going to bear that one in mind. Let's just confirm all of our RCA signals are going in cleanly. So like I said, this is our front left. Okay, let's plug it into front right now. So but based on that fact, we should find 2 pins with some signal on it. There we go, there's one, and there's a second one. Okay, that's looking good so far. Cool. So if we go into the rear now, left rear, I suspect they might be over this side. No, 12 volts. They could be down here perhaps, these ones. Left rear. Okay, there we go. Left rear, we've got RCA input coming on these 2 pins. And right rear, probably going to be these 2. No. Where's right rear? Only these ones. Not that one, not that one. Ah, there we go. There's right rear. Okay, cool. So yeah, we definitely have clean sine waves coming from each of the RCA inputs from the main board into this preamp board. So it's pretty much a certain guarantee that whatever issues we have are going to be on this daughter board here. So let's plug it back in. Remember, we've removed all of the op amps now on here. So I just want to kind of follow the signal coming from the main board into here. So you can see that this is the pins coming in from the main board. Looks like the audio signal ones go mostly, well, they could go anywhere really, but we've actually also got some more op amps over here. There's a couple of op amps over here that I didn't check. There's a 072C over here that you notice. So I didn't actually check that one. So let's just power the board up and just check to see what's on that one. See if we've got any DC on there. There is some DC on there. There's got 4 volts on there. Ah, hang on a minute. Is that a supply pin? +4. Wait, where is this op amp supply? Maybe there's some more burned resistors for this op amp. This 074 doesn't seem to have any supply voltage to it. But I'm wondering whether that's because the supply voltage to this op amp comes from some supply generated over here to do with the LEDs. Not sure entirely. But yeah, this op amp we've got 4 volts on one of its pins, but there's no like plus minus supply. If I just remind myself, the supply should be on pins 1, 2, 3, 4. Should be pins 4 and the one opposite. 1, 2, 3, 4. So yeah, there's nothing at all on the supply pin for that op amp. Let's trace that back. Where does that go? There's a little trace there that goes into this via here. And flip that over, try and follow where that goes. That goes around there into another via. It's possible that maybe this op amp only gets VCC when some of these buttons are pushed down. So let's push some of the buttons down and see whether VCC appears on this op amp now. Okay, so with the button pressed down, we do get a bit of voltage on pin 4. 1.6 volts. Nothing on the one opposite it though. But in my mind, regardless of what the op amp is doing, it needs its plus minus bipolar supplies, doesn't it? Like it needs that to do whatever it's going to be doing. So that just doesn't seem present. So I'm probably going to trace this back to try and figure out where that's supposed to come from. I don't see any more 10 ohm resistors around this area that could be like failed for this op amp. It doesn't really seem to have that. Right, let's power this off and try and follow where that goes. That sneeze came back. It did come back. It came back with a vengeance. Yeah, the LEDs are controlled by the output of the op amps on those MTX amps. I wish I knew more to help. Well, that's cool. That's good to know. I suspect it was the op amps that were controlling the LEDs, because there's a dial that you can move to change the color of the LED. So makes sense. I think it's pre-recorded. No, definitely not pre-recorded. I'm just I'm in the zone at the moment, so I'm not really looking at live chat. Yeah, there should be an aha moment anytime soon. Fingers crossed. Love it when that happens. How's it going, Sergio? What's up? What's up? Right, let's get back to this then, shall we? Right, let's try and find where the VCC goes for this op amp. 1, 2, 3, 4. So, like I say, through this via. Now we should have that come through the other side. Where was that? Can't remember now. It's down there. There we go. So that's that via there. Then we go over to this side. That's underneath. Oh, that's underneath a bunch of caps. That's really annoying. So that's going to be quite hard to follow. Okay. So that via then comes up underneath these caps by the looks of it. So it might be a bit hard for me to follow it from there. But let's just try and find a component that it's supposed to connect to. No, anything? I don't want to have to remove those caps just to follow the traces. A schematic would be really bloody helpful right now, wouldn't it? I doubt there's a schematic of this preamplifier board floating around anywhere. Oh man. So the via goes under here. Yeah, this is pre-recorded. This is actually a pre-recorded stream, but I'm cutting back to a live feed and sitting here at my desk doing nothing except watching my pre-recorded one, so I know when to cut back to a live feed. Thanks Sam Peel for the 20 bucks, appreciate that. Don't quite know what this will get you, but have a great rest of your Saturday. Hope the repair goes successful. Super kind of you, Sam. Man, that's really, really kind of you. 20 bucks will get me, well, yeah, a fair bit of stuff. That will actually get me a new spool of filament for Boom or Bust. So thank you very much. Really, really, really appreciate that. I'm glad that you are enjoying the content enough to feel like donating that much money. Thank you very much. Massively appreciated. Why would they make this go underneath the freaking capacitor? How am I supposed to follow it? Oh, oh, oh! I just by chance found another trace, another via that just so happened to be connected to it. Right, okay, awesome. It goes over... Goes over here. Down here. Up on another trace. Oh, it goes miles away, guys. It goes freaking miles away. Okay. Right, it goes to there. That via. Now, where does it go from there? Come on. Let me follow you through the board. I think the trace goes over here now. Let's keep following it. I think we're probably going to make our way over to the other side of the PCB because that's where the supply voltage is supposed to come from, right? So I suspect it's going to want to go... Ah, here we go. There's another trace with it. Yep. Following it all the way over here. Excellent. So we've made our way over to the other side of the board now via this trace here. So let's put our multimeter on that bit, and let's come up here and follow this trace into that one, into this capacitor. Well, surely it can't just go into the capacitor because it's a DC supply, so it needs some kind of DC. And the other side of the capacitor is actually the 10 ohm resistor that we just removed, that was feeding the VCC supply to this op amp here. So yeah, that doesn't make a lot of sense. That it must go somewhere else as well. That's that one there. Oh, you know what it is? I think that this 10 ohm resistor not only probably feeds this op amp, but it might also just feed this op amp over this side as well. So I think the reason we haven't got any supply voltage is just because we haven't got the 10 ohm resistors in place. So I think that those 10 ohm resistors might be feeding a pair of op amps, and the one over the other side just so happens to be not connected at the moment. So because that op amp over here is part of the same possibly supply for the one that was visibly burned, I'm going to go ahead and remove this one as well and replace it, because it was part of the same kind of supply chain as the one that that was burned originally. So yeah, I'm so good at these live streams now, guys. I can actually predict what you're going to say. So I'm at the moment, obviously this is yesterday. I'm filming this yesterday just now, and I'm able to predict that you're probably going to be talking about maybe whether this is a live stream or maybe whether it's pre-recorded. So I'm just kind of pretending to chat right now. And you see this feed of chat right here. I actually typed all this out because I'm able to predict the live chat so well that what I wrote here today is probably what you're going to be saying tomorrow. So it's probably, you know, I'm very good at predicting the future like that. Then predict the fault. Yeah, exactly. Yeah. Unfortunately, my skills of prediction don't go as far as electronics repair. They only go as far as what people are going to say, sadly. I have 40 different YouTube accounts. Yeah, actually, everything that you're reading in the live chat right now is actually just bots that I've programmed to say specific things, and that I've preempted in advance, so I can like respond to them in my pre-recorded live. Can you predict me asking how much a sponsored boom or bust sticker would cost? I'm not sure. You know what? This has actually been a problem. I've actually been really struggling to kind of come up with this. So obviously boom or bust, I plan on it hopefully getting somewhat relatively popular. So it'd be really cool to have sponsorships because it would help cover the costs of the filament and just stuff like that. But I have no idea what sort of prices to charge for example, like a sponsored sticker in the test cabin or a sponsored segment. I have no idea. It's so kind of far-fetched. It's so different to anything else that anyone else is doing. Like, I can't really Google it to get an idea of price. So I honestly have no idea. So although in every episode I say, yeah, if you want to sponsor this, in reality, if anyone actually messaged me and said, yeah, I want to sponsor this or whatever, I'd probably kind of reply with, just bear with me while I figure out how much this should cost. I literally have no idea. I don't know if it should be something like 20 bucks, 30 bucks. I don't know whether it should be like 150 bucks. I have no idea. I don't even know what kind of price range it should be in, because I've never done anything like this before. It's very difficult. Now, you see, we know which ones aren't the bots, because bots never out themselves as a bot, apart from Nightbot. Be careful clicking sponsorships these days. Oh, don't worry. I have had probably hundreds of emails to my NSV email account from fake sponsorship requests. I can tell them instantly. The reason that I can tell them instantly is because I only really want to have sponsors for Boom or Bust that are audio related. I don't want some nonsense like VPN or some crappy headphones or something. I want, if it's going to be sponsorships on Boom or Bust, I want it to be audio related, so that the stuff that is on there is actually something you might be interested in. Have you ever used a driver that works in place of iOS 21844S? Yeah, I've used quite a few different variants, but I can't really comment on their success, because I don't know if it's just bad luck or coincidence, but whenever I seem to replace the iOS 21844S with a compatible equivalent, the amplifier seems to come back with blown output FETs, after a couple of weeks, and I don't know if it's just bad luck, coincidence, or whether it's because the replacement chip isn't working properly in the board. I don't know, but I've been burned enough times with that I'm now skeptical to actually drop in anything other than the original part number. There have though been ones that I have used, like for example the FAN 7973. I can't remember the exact. I think it's an FAN 7939. No, hang on. FAN 7393. I think it's something like that. There's an FAN chip that is exactly the same as the iOS 21844S, and I used to use it quite a lot. And there definitely are amplifiers that I've used that chip in that have just continued to work for years and years and years. But there's also been ones that have kept coming back, and then after I've replaced it with the iOS version, the amp's been fine. So coincidence could be, but it's scary, especially with the price of MOSFETs right now, for me to test it, for me to try, let's drop in an iX 21844S instead, or a 2EDN version of that chip, and see what happens, because it might be fine, but if the FETs die, then it's very expensive for me. So I don't know why Digital Designs would sponsor me. Digital Designs don't sponsor anyone. They don't even sponsor people for builds or anything. They're very anti-sponsorship. I'm not sure. Yeah, I mean, they might sponsor a sticker. They wouldn't sponsor a sticker. They just expect me to put a sticker in there just because I like them, which I'm not going to. Okay, so I'm going to put a couple of new 10 ohm resistors. I need to be a bit careful actually, because this is the this is the only 10 ohm resistors I have left. I've run out, I need to order some more. So I've got, after this, I've only got 3 left. So I need these ones not to die, okay? Don't die, please. Okay, you behave, don't die. Stay working, please. You are very strong 10 ohm resistor, you will do good job. Limit this current. The thing that I'm slightly concerned about is that the thing that caused these to fail was when I switched the ×1 ×10 button. So, okay, those are back in. I'm going to reconnect the preamp board now. I just want to make sure that we've got VCC going to that TL074C way over on the other side of the board, because it was missing that a minute ago. Just like missing though. Right, so it's powered up. Yeah, we should have VCC over this side now. There we go. Okay, yeah, so those 10 ohm resistors feed 2 TL074s. Okay, cool, good to know. So I need 1, 2, 3, 4, 5, 6. I need 6 replacements. I don't even know if I have 6 TL074s. I have a strip here. Do I have enough? Oh yeah, I do have enough. That's fine. So it's tempting just to replace all of these 074s just now with these brand new ones, but I'm thinking I might just do a quick multimeter continuity check for other components that are semiconductors, to see if any of these are bad in any way, shape or form. So we've got a few diodes on the board here. Now diodes, generally pretty easy to spot when they die. They'll either go short or completely open. So, unfortunately, I don't have a multimeter camera at the moment, but I'm looking for values one way round and nothing the other way round. So that one's good. You just have to take my word for it. That one's good. That one's good. Although these are SOT23 package diodes, they only have 2 of their pins connected to anything in the actual component. So okay, that's cool. How about this big ass transistor over here? What have we got? That's probably some kind of voltage supply transistor. 599, 600. Yep, that one's looking good. This diode should be one way and nothing the other. Yep, that's looking good. Any other semiconductor parts? I'm just going to check some of these capacitors as well. Yep, that's fine. Yeah, there's not really, we've got only 1, 2, 3, 4 diodes that we've checked over this side. Over here, doesn't really seem to be any diodes over this side. So I suspect that it's probably just the 074s. We do have some 072Cs over here. I didn't actually check those. Let's maybe check those. Let's power the board up again. We have all the 074s out, so if I check the 072s, we want to make sure there's no DC on any of the other pins apart from VCC. Okie dokie. So we have 15 volts on there, no DC, no DC on there. That's good, that's good. Okay, that one's looking okay. 15 volts on there, that one's alright, that looks good. Yep, 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 yep. Okay, cool, yeah, those 072Cs don't have any DC on them anywhere. We were getting some, interestingly, do you remember there was some DC on the pins of these op amps before, which now doesn't seem to be present anymore. So we still have, like, yeah, there's some pulses on this one, but I think this op amp here is responsible for the LEDs, so that's fine. don't need to worry about that one, because I think there should probably be some DC or some pulses on this one, because that's doing LED control stuff. That's fine, not worried about that. I suspect this op amp as well is part of the LED control circuit, so I'm not concerned about these two top ones, but these three bottom ones, pretty certain, are for the audio signal, so there should be no DC anywhere on these, which doesn't look like there is. Alright, I'm pretty happy with that. Let's strip out a bunch of new 074s. We need 1, 2, 3, 4, 5, 6. And we're going to solder these to the board manually, not with the hot air, because op amps are seemingly very sensitive to temperature. I've experienced that in the past, so we're just going to use the soldering iron. 1, 2, 3, 4, 5, 6. Yo, Sam, thanks for the $4.99, buddy. Appreciate that. Where should I shoot you a message to get next sticker in the cabin? I build budget boxes, so just let me know. So if you wanted to message me about anything to do with Boom or Bust, the email address is nsvaudio@gmail.com. I'm going to make a space after the @ just in case you're a bot. So if you want to message me, shut up. Yeah, I get that you're cooling down, but you don't have to be so violent about it. Come on, shut up. So yeah, if you want to message me about anything to do with Boom or Bust, then that is the email address to message me at, and I'll get back to you. Yeah, same, Kevin. Not really a big fan these days of digital designs, to be honest. My wife and I own multiple small businesses, one of which has the opportunity to sponsor customers' vehicle builds. We stopped doing that years ago. Do you sponsor anyone for amp repairs? Nah. Like, I barely make enough money as it is. Like, I don't have spare cash laying around for sponsorships for me to sponsor amp repair stuff. So yeah, no chance. Could the 10 times sensitivity button be shorted? So a button can't really be shorted. Like, if a button was shorted, it would just constantly be on or off. So the button isn't the issue. It will have been a voltage that button was sending to one of the op amps that was causing there to be this issue as a result of another leaking op amp somewhere else. Stupid question, says Vex, but would a sub box made out of concrete sound good? Now, I'm guessing that Vex has sent this question in. He's probably going to send it in tomorrow when I actually live stream this this pre-recorded video. But if Vex asks this specific question that my bot that I created a channel for that was also called Vexed has actually just sent in, would a sub box made out of concrete sound good? Depends really. What you were expecting from it. In terms of output, it would be about as loud as it could ever be. So for a given box volume and box design, being made of concrete would mean that there is absolutely zero baffle flex, wall flex, enclosure flex, or anything inside. So it's going to be as loud as that design could ever possibly be. In terms of whether it sounds good, that's just down to the enclosure design. So if the enclosure design is a nice sounding design with the driver that you've used it with, yeah, it's going to sound fine. Being made out of concrete, the actual material that it's made of, for subwoofer application isn't really going to change the sound of the of the thing. Basically, what I'm trying to say is, if your sub box is introducing a tone or a sound on top of what the driver is producing or on top of what the sine wave is, that's bad. That's distortion. That's not like something that's desirable. Okay, your sub box ideally shouldn't color or distort the sound in any way, shape or form. So being made out of concrete, it's not going to have any flex or vibrations or anything like that. So it's not going to add any distortions from that to the sound. The only thing I can think of is with concrete, unless it was absolutely dead smooth, unless you like skimmed it or you built it in some way so that the walls were like dead smooth, then the concrete, if it was like textured or bobbly, you might end up getting some chuffing, some kind of air noise, as the air creates eddy currents as it passes over the uneven surfaces in the ports, for example. If it was a ported box, that might be an issue. But if it is a sealed box, it's going to sound freaking amazing. Like, you could stuff the box with obviously some stuffing, as you would a normal sealed box. But yeah, being made of concrete would actually be great. And yeah, for sure, no problems there at all, I don't think. When I got a batch of MTX amps, several of them had dirty pots on the daughter board. Yeah, I've seen that as well. And seeing as that is an issue, actually, just before we fit these new op amps, it might just be a good idea to just take some isopropyl alcohol, just clean up all the potentiometers on here. Like, while we're here, why not? Just in case that's causing any issues. Like, I personally can't really see how dirty potentiometers would cause would cause one of the op amps to burn here. Like, yeah, I can understand how it might cause the sine wave to be distorted, but I can't see how it would cause excessive current draw. But who knows? Maybe some weird kind of thing might be happening that would cause it, but yeah. But yeah, concrete boxes, TLDR, in summary, good. If you can build a concrete sub box, then sure, go for it. It's going to be heavy as hell, not going to be very practical, it's going to be weigh an absolute ton, and it's probably going to be a little bit tricky to build, unless you're really good with concrete and stuff, and you know what you're doing. But yeah, if you can do it, then it's going to be great. Yeah, exactly. Davo says, yeah, but the car's shocks were bottomed out. Exactly. The swings and roundabouts. Hear me out though here, right? Isn't 3D printed concrete a thing? I'm sure that I've seen that, or maybe I've just made that up. But if you could 3D print with concrete, then you could actually make a concrete sub box. It wasn't that heavy, because you could do the same thing that we do with regular PLA 3D printing, where you have infill that is like hollow. So normally, if you're building a concrete subwoofer box, the walls are probably going to be solid, aren't they? You know, you make a mold and you fill it in and you pour it in and it's all solid. Whereas if you were 3D printing with concrete, you could probably make the walls quite thin with infill, and it wouldn't be as heavy as it would if it was just completely solid. Hollow 3D prints filled with concrete are a pretty common thing now too. Yeah, well, that's another thing, obviously. Yeah, 3D print it, fill it with concrete, good to go. They build houses with 3D printing. Oh, I feel like I saw a video on that a while back actually. Straight up, we have an MTX 4-channel, an MTX Thunder 4-channel with a preamplifier issue that we're currently trying to resolve. Okay, so let's get these op amps replaced. So we're going to line up a bunch of flux on these pads here. And we're going to replace these with the iron, just to keep any heat out of the op amps, because they are quite sensitive to it, it seems. Okay. Still waiting for the dual reflex enclosure. Yep, coming soon. I've increased Boom or Bust production to twice a week. So there's going to be a Boom or Bust episode tomorrow. I'm going to be filming Boom or Bust this evening. So after my live stream, I'm going to have some dinner. Then I'm going to film Boom or Bust. And then I'm going to spend the entire day tomorrow editing it. So my Sunday will be spent in front of the PC editing Boom or Bust to be released tomorrow night. So tomorrow night, Boom or Bust. It's going to be a really fun one. It's going to be really good. I've no idea how this box is going to perform. It's either, this next box is going to be either one that performs freaking incredible or totally crap. Don't know which one of these it's going to be, but I doubt it's going to be in the middle. It's going to be either totally awesome or totally crap. So it's going to be really, really interesting to see. And then once I've done the one for tonight, the next Boom or Bust enclosure might be a 5th order, might be a 6th order shootout where we have like 3 or 4 6th orders all together. I've got some cool ideas for the shootout that will be a slightly different video format to a regular Boom or Bust, so look forward to that. Yeah, then I've got a few dual reflex enclosures that I'm also going to do a shootout style video for as well, so keep a lookout for that. Yeah, I've got lots of exciting Boom or Bust things coming. What's causing that to not sit flush to the board? Is there something? Oh, I see what it is. There's a via here that's actually like got a massive protrusion on it. There we go. Sort that out. Okay, that's one. Next one. Let's zoom in a little bit over here. There's two. Has anyone sent in ABC? So I've had a couple of boxes sent in. The thing with ABC is that different people have different descriptions of what an ABC box is, definitions of what an ABC box is. So I've got one ABC box sent in by the original guy who coined the term, the ABC box. But I've also had an ABC box sent in by someone else who used ABC in a different way, used the ABC sort of like terminology in a different way. So basically, yes, I have had ABC boxes sent in different forms, and we shall see how they perform. Okay, that's 3. 3 more to go, I think. I've also had a Paraflex design also submitted, which is great. Definitely excited to see the Paraflex. Something weird though that I noticed, right? If you watch the last episode of Boom or Bust with the T-line, look at how crazy the camera flex was. Listen to how distorted the microphone was, okay? It was quite intense. Then go back and watch the episode with the half-wicked one. In the demos, the half-wicked one didn't seem anywhere near as potent as the T-line did in the demo content. So I've kind of got my head scratched. I'm thinking, and especially as well, the half-wicked one, the driver was unloaded heavily at the 25 scaled hertz, and I couldn't even reach the full 15 watts. Yet it still put up a 145 at 25 scaled hertz. But the T-line, even though it was loaded quite nicely at 25 scaled, and I was able to push all the way up to the full 15 watts, was 5 dBs off. I'm wondering whether something has changed, something has happened either with the sensor or the software where some calibration has gone out of whack. Because I can't get my head around how the Wicked One could be 5 dBs louder while the woofer's basically completely unloaded and not even able to reach the full 15 watts than the T-line, which was visibly louder in the demos. So before I actually start filming Boom or Bust tomorrow, I'm actually going to rerun the half-wicked one just to confirm that it's actually still putting out the same dBs and something hasn't gone weird with the software or the sensor, because it doesn't really make sense. Like when you look at the two videos side by side, the T-line was obviously far more intense. Very strange. The speaker did break in a little bit more over the course of the few episodes, but it was only the FS dropped by about 10 hertz. But that happened before the half-wicked one was tested. That was in between my benchmark error report and the Derek V5. So the woofer TS parameters were the same between the half-wicked one and the T-line. Maybe I should rerun the TS parameters on the woofer just to make sure it's still alright, but I've been very careful with it. I don't think the woofer's hurt. I'm just using a regular SPL lab meter. Right, that's 4. 2 more to go. Has the watt meter gone out of whack? I don't think so. I think I would notice that because the driver behavior would be very different. Like if the watt meter was well out of whack, then I'd either start breaking the woofer mechanically, or it would start burning the voice coil if the meter was reading too low, or if the meter was reading too high, then I wouldn't be able to I wouldn't be able to reach mechanical excursion limits or anything like that. So no, the watt meter is fine. But I do just want to rerun the half-wicked one just to make sure everything's still the same, because I don't know, it just seems like a huge difference in dB level, but on the videos it just doesn't look like it's as loud as the T-line. It doesn't really make a lot of sense. Right, one more. One more to go over here, this side. Yeah, the cabin structure is still perfectly fine. It's a really solid piece of wood. You know, it's not. Yeah, the cabin like surfaces vibrate a tiny bit, but you know, yeah, the cabin's not going to be affected by the sounds in any way, shape, or form. Okay, that is now all 6 op amps replaced. Let's just spray some isopropyl alcohol to get rid of any flux that's on there. So I'm hoping that it was just op amps that were the issue, because if it's not, then it's kind of tricky, because there's not really any other components on here that are likely to, you know, leak voltages and cause this issue to occur, really. The only thing that it would really be would be op amps. We checked the 4 diodes, but they're to do with the LED circuit, not the actual audio circuit, so that's not an issue. Okay. So, I'm going to plug her back in. Going to put this little case on my lap for reference of the buttons and stuff. So we want it in 4-channel mode to start with. Gain, let's turn it up a little bit. Crossover off to start with. Gain down on the rear channel, crossover off. That doesn't matter. Colour of the backlight, prism effects on. Low pass doesn't matter, high pass doesn't matter. Mono, keep that off. High pass filter, keep that down for now. Input sensitivity times 10. And 4-channel mode. Yeah, cool. Right, that's all looking good and correct. So let's check each channel individually. So we're going to start off with the front left, which was absolutely fine previously. There was no issue with the front left before, so it shouldn't be now either. Let's see. Front left is here. So you should have a nice clean sine wave on front left. Okay, cool. Nice clean sine wave on front left. Let's check front right. Actually, it's just, oh no, we've still got that nonsense wave going on rear left. What is going on? I'm wondering whether it's something on the main board. There shouldn't be anything on rear left right now. Front right, that's good. Rear left, rear left is still fucked. I think it's something on the main board that might be back feeding into the preamp board. Rear right is fine. So it's rear left that's got an issue. Rear left has an issue, but I don't think the issue is on the preamp board. And we can actually double check and confirm, because we can have a look at the pins coming out of the preamp board, and if the audio is clean coming out of the preamp board, then we know the issue is on the main board somewhere. Right, so we have left front. So basically the biggest issue really here is that left front left, when that's plugged in, we shouldn't have anything on rear left, but we do. We have this nonsense on rear left. So let's see what we've got coming out of this board. We should have 2 sine waves, one going in. Here we go. So we've got the sine wave going in from the main board, which is these 2 pins. And then we should have maybe just one going out, which looks like that. Oh yeah, look, we've got this weird waveform on this pin here. What is that? I bet that's only present on rear left input. If I plug in rear right, what does that look like? Nice clean sine wave. Sine wave going out. Nothing else weird. Okay. Rear left going in. Sine wave there. That's coming out. So that's the sine wave going in, rear left. Sine wave coming out is this one here. So that's our sine wave coming out of rear left. So if I plug in front left now, we have that coming out of rear left, right? So is that just an issue on the preamp board, or is that something feeding back from the main board? The only way that I'm going to really be able to know that for sure is to isolate the preamp board from the main board, like just that pin, just like disconnect just those pins somehow, which I can do because I can actually just desolder the pins from this header. So you see this header, right? What I could do is I could pull the pins out from underneath. So for example, this pin here that I want to isolate, I could desolder that pin and pull it out through the plastic so it's not part of the circuit anymore. That would be easy enough to do. But maybe I should just, with the amplifier off, follow that on the main board and just see where that goes. Just to see if I can see any faulty components on the main board that follow that path route. Right, so this is the problematic pin, which is rear left. So all I need to do is find a component on the main board that has continuity with that pin. So I can't see the underside of this main PCB because I haven't unscrewed it from the main board yet. But I'm just going to see if I can quickly find continuity just with my multimeter here. So I don't think it's going to be anything to do with this circuit. I think that this circuit here is the power supply. I've got a feeling that this circuit is probably to do with the power supply. So I suspect that the audio signal out from the preamp board probably goes straight to the drive circuit, which is over here. So all I've got to do is find a component that has continuity with this pin from the preamp board, which might be easier said than done. Just before I go probing around, I'll make sure there's no rail voltage left on the board. Probably not, because this is class AB, so it shouldn't really hold rail voltage. No, there's no rail voltage there, that's good. So I'm just going to do the old thing where we scrape around with the multimeter, listening for the continuity beat. There we go, there it is. Okay, so that's where the rear left goes to, there. So I guess what we could do is like have a look at some components over on this side of the board, see if we can find anything that's like faulty over here. And now that we know where that pin goes to, I can remove the header from this. Oh shit, which one was it again? Make a mental note of the part number. It was R825. Okay, so R825. Let's remove this header. R825 is... which pin is that? This one right here. Okay. Now, remember earlier we saw a pin that had like 5.7 volts on it. And I was like, I don't think that's supposed to be there. Do you remember? I said keep that pin in mind. Do you remember earlier when we were checking the voltages on this header and I was like, okay, we've got sine wave input over here, plus minus 15 volts, plus 5 volts, and there was one pin over here that had 5.7 volts on it. And do you remember I was like, keep that pin in mind. I don't think that's supposed to be there. Well, I think that's this pin. So I think there's an issue on the main board that's killing the preamplifier circuit. So let's power up the board without the preamp circuit attached, and let's see what we've got on this stanky pin right here. Oh yes, would you look at that? There we go, 6 volts DC. Okay, so there's a problem on the main board. R825 over here. Let's zoom in on the drive circuit over here for the output. R825, what are we saying, my friend? You've got DC on there. Okay, there's no DC on the other side of R825. So that means that we must have continuity to some other component. So let's turn the amplifier off and get checking for continuity. Let's wait for that rail voltage to sink down. This is a proper whodunit, it absolutely is. Okay, there we go. Rail voltage should be down at ground now. So 825 is this one right here. That has continuity to our pin on the preamp board. So what else has continuity to R825? Because we had DC on this side of the resistor, but not on this side. So that means that there must be something else connected to, here we go, D804. What are we saying, D804? Are you shorted? Okay, we have 649 one way and 1186 the other way. Let's compare that to a similar circuit on one of the other channels. Because it's a 4-channel amplifier, we actually have the benefit of having, you know, multiple channels here that we can compare to that are working. So this diode here is reading 1180-ish this way round. So we want to make sure that it's the same on this one. 1175, yep, so this diode is probably okay. Okay, what else do we have continuity to? Q813. Let's just check for shorts on that. Check for shorts on this diode right here. 666. Oh, we've got the devil. This component is reading exactly 666 on diode mode. Ah, who remembers there was a stream a while ago? What stream was that from? Well, I was repairing some amplifier and there was a bunch of parts that were like reading dead on 666, and it was like, oh, the devil's in this amplifier. It was quite a funny stream. I can't remember what amp it was now. 666 on that one. So let's compare that to another one. 664. Flip probes. Okay, that looks the same as the other channel. Not a problem. Probably unlikely to be an issue there. Okay, let's keep going. What else might be around here that could be bad or could have continuity to our input? You know what? It could actually be a dead output transistor. I didn't even check them. It could be a dead output transistor. We've got 391, 443. Okay, how about this one? 391, 440. No. 440, yeah, no, I think these are all fine. Okay, what else do we have continuity to over here? So we have this diode. We haven't found anything else other than this D804 so far. Oh wait, here we go. We have R824. Okay, so there's another place where there's continuity to our preamplifier pin. And another one here, R828. So we now need to power the amplifier up and see which one of these resistors has the same DC or higher on the other side. Remember, we're trying to find a component that's leaking DC back to the preamplifier board. So we just need to follow the traces, and whichever components have the same or more DC on the other side of them is where that DC is coming from. So we know that the DC isn't coming from the other side of R825, because although we have DC here on that side. On the other side we don't, so it's not coming through 825. So let's have a look at 824. So we have 6 volts on one side, on the other side, whoa, so much is beyond my scope. Right, hang on. Oh, we've got 31 volts. Sheesh. Okay, well that's definitely not right, I don't think. What about this one, 828? We've got 6 volts there. On the other side, we've got 5.7. Okay, so it's coming from here. R824, 31 volts. Okay, that's a bit more like it. Now, where the heck is that coming from? Looks like this trace for R824 goes off to a few other places. Looks like it goes to a few transistors here, actually, which is interesting. Let's have a look at this diode real quick. Okay, so it's not the diode, right. Okay, let's power the amplifier down. Wait for the rail voltage to sink down to ground, and yeah, let's see what components are connected to 824. Looks like there's a transistor up here, 613. Another one. There's a bunch of transistors actually, which is really interesting. Looks like that might be a supply for a 6 volts here as well. Okay, I think my stream just dropped out there for a minute. But okay, what's interesting is that it's right. So this is a 4-channel amplifier. These are the 2 rear channels, right? So these are going to be identical, right? We're going to have a working channel and a faulty channel. So we have R825 here, okay? That has 5.9 volts on it that shouldn't be there, okay? We have R824 that has continuity to that resistor, and on the other side of it, it has 31.5 volts. If we look at that exact same circuit on another channel, we have R524. We do have the same 31.6 volts. On the other side of R524, we have the same 5.9 volts. However, that doesn't seem to... Oh no, we see on R525, we still have the 5.9 volts. Oh, that's weird. So am I barking up the wrong tree here? But we only have the DC on one of these pins on the preamplifier thing. That's definitely an audio output, isn't it? Oh, 825. Right, let me just confirm a couple of things here. Right. So this pin right here had 5.9 volts on it. That's connected to R25 over here. We have the same voltage on, sorry, R825. We have the same voltage, the same circuit, R525 here. Is that an audio? That's an audio output. That goes to here, this pin. Oh, no, it doesn't. It goes to, no, not that one. Doesn't go to any of these. Okay. I don't think that this pin is supposed to be connected to this R825. I think that there's something shorting this pin to this trace that's not supposed to be there. So it looks like the audio output goes from here to R825, which is maybe where the audio is injected into the drive circuit. But I don't actually think that's supposed to happen. What we might have to do is remove this circuit from this base plate and follow the traces for the other channels and see where they get injected into the output drive circuit. And from doing that, we can then identify whether that pin is supposed to be connected to that resistor, because it doesn't seem like it should be. Yeah, okay. I'm going to remove the circuit, the board from this bottom tray, and that will allow us to look a little deeper into the follow the traces from that header, see where they lead to in the drive circuitry. Yeah, let's get my screwdriver and get that out. Hello Luna, how's it going? Thanks for jumping on stream. Should come out nice and easy. There we go. Oh no, the wires are like stuck in there. I'm going to have to remove them and reconnect them again. It's annoying. Okay, right, let's take a look on the bottom of this board then. Let's see what we've got going on these traces. Okay, so firstly, just a visual check to make sure that none of these pins are shorted against each other, or nothing has got into this board that's shorting across any pins. No. Okay, great. Next thing that I want to do is identify which drive circuit is actually, or it looks like there's a bunch of water ingress over this side of the board. I'll clean that up in a minute. Don't think that's causing our issue. That's way over here. Let's just give it a spray anyway. A bit of damp got in there. Next thing I want to do is identify exactly which drive circuit is for the rear. I think it's the rear left, isn't it? That was the issue. Yeah, so the issue channel is rear left. So if we take continuity, which output transistors are responsible for rear left? Oh, it's weird. They're kind of like flipped. So there's one transistor here for rear left, and the other one's over here. Bloody hell. So that means the audio signal probably has to go to both of those parts of the circuit. Maybe. What a weird way of doing it. Yeah, it looks like you've got like these jumper wires that go like across the board here to the other side. Shit, I would have thought that they'd have the two transistors like next to each other, but no, they're opposite. So the drive circuit for the rear left is going to be here and over there. Okay. Right, let's identify where the audio signal comes out of this header for like a good channel, for one of the good channels, for example. Maybe we can just follow one of these traces. So if we plug this board back in, okay, let's follow where the audio comes out of for rear right. Rear right is working correctly. That's working as intended. So if we just pop that there, plug in an RCA for rear right, which is probably going to be this one, I think. I've removed the front panel, I'm not entirely sure. Yep, rear right is that one. So power up. Make sure there's no solder on the bottom here. That's going to short out anything. So rear right down here. Okay, so yeah, there's some signal there, rear right. So what pins is that? Let's, how do I figure that out? Flip the board over, I think. Let's pop that down there for a minute. So if I flip the board up, we can figure out which pin is responsible for rear right. So we're going to see our RCA in and then our RCA out. Okay, there's our RCA ins, these two middle ones. So our RCA out, our signal out is going to be, okay, this one right here. It's 1, 2, 3, 4, 5. 5 in from the right. Okay, fantastic. So, for rear right, which is a functional channel, a channel that's working perfectly fine, the pin that is responsible for sending the signal from the preamp board to the main board is 1, 2, 3, 4, 5. This one right here. This doesn't have a trace on the bottom of the PCB, so we're probably going to have a look, see where the trace goes on the top of the PCB. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I don't see a trace on the top of the PCB either, so it could be like multi-layer. It could be going inside the PCB. Yeah, don't see a trace on the top either, so it's probably like somewhere in the middle layers. Annoyingly, let's see if it pops up somewhere on one of these vias. 1, 2, 3, 4, 5. Okay. Oh, there we go. Looks like it might be that one. Any of these other ones? See if it pops up down this way at all. Okay, so I think it's literally just this one here. So we follow that. That goes round to here. Does that pop up anywhere else, or is that going into components now? Okay, probably going into components now. So that's this big, thick, chunky girl on the top. Yeah, this board is super multi-layer, so that via doesn't actually come up to the top. That makes it quite difficult to trace things because we don't have visible vias on the top and bottom that we can kind of go between. So we're just going to kind of have to, we can hold this up to the light possibly and see. Unless it's that one, maybe it's that one there. Ah, there we go, it's that one, it's that one. Right, so there, goes to there, goes to... Where did that go to again? Somewhere down there. Okay, goes to this big chunky capacitor right here. Okay, big chunky capacitor. So that means that these big chunky capacitors, these 22 volt 50, 22 UF 50 volts, should also have the input signal for all the other channels on them. So if I go ahead and check with my multimeter, these other capacitors, I'm going to assume that was for that one. Let's have a look at, so it's on the positive side, so we should have continuity on this capacitor here or one of these two capacitors to another one of these pins on this board here. There we go. Yep, we've got continuity to that one. Okay. And then on, so that's 1, 2, that's audio, probably audio input from there. Then we've got another one over here somewhere maybe. Aha! I think that was our problematic pin earlier. So we found another place that it has continuity to. Okay, cool. Now the interesting thing will be is, does this other channel that we've just followed the traces for, that has continuity on this pin, does that also have continuity to the resistor up here? No, it doesn't. Doesn't seem to. Okay, let's power it up and just have a look at what voltages we've got over on these caps. Because I suspect these caps might be for DC filtering, blocking on the signal. So this capacitor over here is, we know for sure, definitely for signal. Almost certainly. We've got -2 on there for some reason. -2.5, positive 5.7, -1.8, etc, etc. Okay. So -2.6 on that one for some reason. On the other side, nothing. On this one, -1.8, 0, 0, 0, 5.7. Oh, it's proper weird, it is. It's a proper weird one. Thanks very much, Dank420 girl. 25 bucks, holy crap, thank you so much. That's a massive amount of money to send a random dude on the internet. Thank you very much, Dank420 girl. I will try my best to keep up the hard work, try and get this thing sorted. "72 layer PCBs, bloody hell. I would not want to work on something like that. I've seen some videos of people repairing graphics cards that have like snapped PCBs, and they're like grinding down each layer of the PCB to get to the snap traces. That's pretty crazy stuff. Right, okay. I really wish I had a schematic for this right now. Maybe I should go looking for a schematic, because I just want to just double check and confirm which one of the ones of these are supposed to be the audio outputs from this header here. I suspect that it is the ones that we found, but I just want to like get a good reference and double check and see exactly where they're supposed to go, because like I say, one of them has DC on it that's not supposed to be there. So I've just plugged in this board back in now for a second. I just want to check what's on all of these output pins here. Not got any signal going in so far. So nothing, nothing, -14. Okay, so this is upside down now. Positive 11.3, positive 4.9, 15, nothing, 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 nothing. Okay. So in terms of signal then, if we drop a signal in here, So front left shouldn't result in any signal on the rear, except it still is. So which part of the circuit is doing that? Is that up here? Yeah. Let's go in one of the good channels. Front left. Yep, front right. So we know that front right is absolutely fine. There's nothing wrong with front right whatsoever. So, a correct channel then, by the looks of it, is supposed to have, on this diode, we're supposed to have audio on, we're going to like have half of the pulses on this side, on this diode. On this diode we're supposed to have the audio on one side and then riding up to 5.7 on the other side. These transistors here, audio, nothing, because that's probably for the other side. So if I go to the other side of the board now, let's have a look what's over here. Right, this transistor here is front right, and I just want to see whether this part of the drive circuit has got anything to do with that. It doesn't look like it. Oh, there we go, they've got a sine wave there. See, it's all spaced out so weirdly, it's very, very difficult to follow. Very difficult to follow. What I'm tempted to do actually in this instance, right, so because I want to try and identify whether the issue is on the preamp board or the main board, because I'm still not entirely sure. It looks like the issue might be on the main board because we've got like DC and stuff coming back from the main board when we have a channel plugged in that shouldn't be playing. What I might do is I might inject some RCA signals, some sine waves into the main board without the preamp board being there. Okay, so what I might do is remove this, okay, and inject some sine waves directly into these pins so that we know for sure whether it's the main board that's causing an issue or whether it's the preamp board. So in order for me to do that, I need to absolutely be 100% sure. I need to probably draw a diagram of which pins on here are responsible for the signal output to the main board from here. So is this just a direct mirror image of that? Let's have a look at the pins on here. Whew, this is turning into a bit of a headache, this one. So that bottom one there, okay, it's mirror flipped by the looks of it. So that top one becomes that bottom one. Eesh, it's not useful. Okay, I'm just going to quickly check which ones of these pins are responsible for the signal output. So I've got some signal going in on the RCAs. I'm just going to plug in each RCA and see which one of these pins is supposed to be for the output. I'm going to bring up probably Notepad or something on the PC so I can write it down. How many pins we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 along each side. So if I flip that around, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I've got my 10 pins written down in Notepad. So let's start here and let's see which. So I've got, this is front left plugged in so far. So front left, which one of these is front left signal output? Looks like this one. So that is 1, 2, 3, 4, 5, 6. 6 along on the bottom. So I'm going to write front left on that. Now if I plug in front right, let's have a look at which one is front right. Looks like the 5th one along. FR. Okay. Rear left. This one's the one that looks a mess, remember? Looks like it's this one, which is the 4th one long. Looks like they're all in a line, which is nice and handy. Rear left. And rear right probably is going to be the 3rd one along, if that, yeah, 3rd one along. Okay, they're all nicely in a line. Great. If I plug this one into front left, then do I get a little bit of signal on pin 4? No, I don't. That's weird. Wait, hang on a minute. issue, right? Yeah, okay. That's the issue right there. That's the issue right there. So it's currently plugged into front left. Alright, cool. So now that I've got that all written down, what that now allows me to potentially do is to inject my own signals into this, which will completely isolate whether this daughter board is the issue or not. Another potential thing that I could do instead would be to supply this daughter board with its own auxiliary supplies from an external power supply and inject some RCA signal into it and see whether we get that weird issue on rear left coming out of the daughter board. So I'm not sure which one I'm going to do yet. I'm either going to inject signal into the main board, which I think is probably easier than setting up auxiliary supplies for this one. The balance pot for the trouble channel and see what the signal does. The water intrusion is suspect. The biasing potentiometer, do you mean? I could try moving that a little bit, but I can't think why the biasing potentiometer would cause there to be audio moving on one channel versus the other. Like, it wouldn't, even if that was messed up inside the biasing potentiometer, it wouldn't cause audio to be present on one channel versus the other. So yeah, not sure that that would be the case. I might rebias the whole amplifier anyway, but for now I think I'm going to flip this over. Bottom ones there become the top ones, so our signal outputs become these top ones now. So our signal outputs now become 1, 2, 3, 4 here from the daughter board. So I could inject some signal from my signal generator, and I'd have to give it a ground reference probably, but that's okay, I can do that probably just by injecting some there. Yeah, provided it's got a ground reference, so I can just check continuity with my signal generator on some of these pins. There we go, got a ground, is that a ground reference? Yeah, that's a ground reference there. Ground reference there, oh, yeah, so we've got a ground reference, that's okay. So all I need to do is get a piece of long wire and inject some signal into front left and see whether the weirdness happens on the output channel for front left. If it does, then the issue's on the main board. If it doesn't, then the issue is still on the daughter board. Right, let's find a little piece of wire to do that with then. Might need to go, there we go, one of these. Now I just need a singular long piece of wire, which I have in the old workshop. So bear with me while I grab a singular piece of long wire. Here we go. Okay. So I just need to plug that in to here. So this is now going to go to my signal generator with a piece of bare wire as well, in addition to the RCA. Yep, cool, looks good. Now I just need to solder this other end of this bare wire to a little header that I have, little sort of connector wire that I've got here, little orange one. Actually, I'm not sure why I'm even doing this. I could have literally just jumped over the signals from the input to the output here. Why didn't I just do that? Duh, that's pretty obvious. Why am I doing all this nonsense with my signal generator here? Why don't I just bypass it by jumping over the input signal from one of these inputs to the required output? Right, there we go. Let's do that. That's much easier. Much more simple. I don't know why I try and make things hard for myself. Right. Power supply on. RCA signal going in. So I've got front left going in. So let's find where front left is on here. Okay, there's front left, as you can see on the scope. So let's keep that nice and low amplitude. So I just need to jump this over to one of these other pins up here. So let's connect that there. And then that just needs to connect to probably going to solder these two pieces of wire together just so that I've got an actual header for the other one. Mr. Big, thanks very much for the kind words in the live chat, buddy. Okay, cool. So 1, 2, 3. This third pin long was front left, wasn't it? So if I connect that to that, then we should get output from front left to the amplifier section. Correct? Let's have a look. See what we got. Yep, there we go. There's output from the amplifier section from front left. Excellent. So the biggest question now is, Does that signal also appear weirdly on rear left? Yes, it does. The issue, my friends, is on the main board. Mamma mia! So that means that that signal is probably also weirdly coming through on this next pin, not this one, but that one. This is weird. So yeah, the problem is on the main board, not on the preamp board. Right. So, okay. How is there? So I've got a signal going into front left just now, just here, okay? How is there signal back feeding or somehow also making its way onto rear left? Those channels should be completely separated. The only thing that I can think of is like a trace shorting to where it shouldn't be or something like that. It's really weird. It's on the main board. On the bias potentiometers, we don't really have any. There's no audio on the bias potentiometers, so that's not the issue. So rear left shouldn't have that on it, but it does. It's up here somewhere, isn't it? It's like so weird. Right, let's follow the pathway for the front left input. Let's have a look. Where do you go? Front left input goes all the way around there via that trace to that part of the circuit. So you go over there into that via there. Why can't I find that now? Okay, so signal goes to D504 over here. So I'm just checking the continuity of the good channel, which is front left, goes to this trace here. Okay, can we find also where, for example, front right goes? Where does front right go? Does that go to a similar location? Trace then goes down here. Does it go past there into that via, which then probably makes its way into this capacitor? So it looks like the audio signal makes its way into these great big capacitors here. I don't think it makes its way through the capacitor, but it goes into the capacitor, probably for some kind of smoothing or something like that. Should we follow the signal through? So after it gets to that capacitor, where does it then go? Man, a schematic would be really freaking useful right now. Okay, it goes through the capacitor, that's good to know. After it's gone through the capacitor, where does it go then? It is class AB, this one. So after it's gone through the capacitor, then where does it go? Maybe I should change my approach here. Maybe I should just start looking for like dead or shorted components rather than trying to trace stuff. Maybe I should just test every single semiconductor component around here to see if any are shorted or anything like that. Super weird this. This is why I hate Class AB. If this was Class D, this would be so much more simple. Like, this wouldn't happen. If this was Class D, I'd just be able to follow the PWM through the drive circuit. Probably found the issue by now. Class AB, properly hate this kind of nonsense. Does anyone do a little bit of schematic searching for me? See if you can find a schematic for an MTX Thunder 5604. See if you can find a schematic for that. Because that would be super useful right now. One thing that I'm finding really interesting is our bad channel, so our rear right, no, sorry, our rear left. Do you remember how it has continuity to this resistor up here, R825? I don't think any of the other channels have continuity to that resistor, like that kind of same resistor for that channel up there. So maybe that's our problem. Maybe we just need to find why there's continuity between these 2 points, and then maybe we'll find our problem, because I don't seem to see that there's continuity between any of the other channel outputs and that pin there. So that is 825 has continuity to, it's like this transistor, this resistor, this resistor, this diode, etc, etc, and this resistor here. So if that was supposed to be like that, on this next channel we'd also have continuity to these resistors and diodes, which we don't. So that's our problem. Our problem seems to be that we have this capacitor here connected somehow to this trace. So what am I now looking for a piece of wire strand that's got somewhere? So that shouldn't be connected. There should be no connection between these two. I think that's our problem. So how do I go about identifying how that's like happened? Following this trace down here, following this down here. It's this trace here. The thing is, it looks like it's supposed to be. If you follow the trace with your eyes, it really looks like the trace actually connects there. That goes up there to there. It's just kind of how it is. I'm thinking to remove this Q807 just so I can see this trace a little clearer under here. Maybe that's not supposed to connect there. Like, none of the other channels have continuity between the capacitor here that's supposed to be the amplifier input, right? The audio input to the drive circuit, and whatever this circuit is up here. None of the other channels have that continuity with that same part of the circuit. Nope. 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 So I'm just kind of a bit suspect about this transistor. This is where the trace goes under, so I just want to see what's under this transistor, just so I can look at the trace a little bit easier with my eyes. So this is the trace for the audio input to the drive circuit. Comes up here, here. No way! Ladies and gentlemen. Ladies and gentlemen. Wait a minute. Wait a minute! Right, who's paying attention? Who saw that? Who understands why my mind is just blown right now? Who was actually paying attention there? Would you like me to explain what just happened? What the f... How did I even find that? How was that even a thing? Mind is literally bamboozled right now. Wow. What the heck? I want to get the microscope out. I want to see what the heck that was all about. Right, guys. So, recap. This amplifier came in with an issue that the rear channels weren't playing. The preamp board was burnt up and smoked on the op amps. Fixed that, we plugged it in, it burnt up again. Fixed it, haven't really plugged it back in the same way so it doesn't burn up again. We have noticed that when I plug in an RCA to front left, we also get output on rear left, but it's terribly distorted and looks bad, and if you turn the gain up too much, it smokes the preamp circuit. So that's weird in itself. But anyway, we've been trying to diagnose whether that issue is something on the preamp board or something on the main board. So to isolate those two things, what we've done is I've just bridged over the RCA input signal that would otherwise go to the preamp board and just routed it straight back into the main board, completely bypassing the preamp section entirely for the filters and stuff. By doing that, we've found the issues on the main board. So when signal is applied to front left, we get weird distorted output on rear left as well. So I was looking at the pin which comes from the preamp board for rear left, the problem channel, noticed that it had some DC sitting on it and the other pins didn't have any DC sitting on it. So I was like, right, where does that pin connect to? Noticed that the pin for rear left connected to some resistors over here on the drive circuit. So I was thinking, okay, well that's obviously where the signal gets injected into the drive circuit for amplification. However, Turns out that's not the case, because all of the other correct working channels don't inject their signal up here in this part of the circuit. The signal gets injected to these capacitors, which are DC blocking capacitors. You can see here, this capacitor here, which is for front left, which is a correct, good working channel. We have continuity from the pin coming from the preamp board to this capacitor, and nowhere else. It doesn't have continuity to any other part of the drive circuit. However, the pin for rear left, which is the one we are having a problem with, seems to have continuity to a couple of resistors up here. And I was like, why is that? I was looking at the trace, and it looks like, to the naked eye at least, that the trace that goes from the DC blocking capacitor that is supposed to be for the rear left channel, which is this one right here, this is the correct injection point for the signal for rear left, seems to also go up here very close to these resistors, and it looks like it connects to them, like it genuinely looks like it connects to them. But yeah, and I was getting continuity. So because the trace passes underneath this transistor here, which I've just removed, I was like, I want to remove that transistor to get a better look at the trace and try and figure out where it actually goes. Having just removed that transistor, the continuity between this capacitor and these components is now no longer present. Do I know where the continuity happened? No, I have no idea. I literally have no idea what I just did. By removing this transistor, the continuity is now gone, which is good. I'm happy, but I don't know what I did. I just removed this transistor. Maybe there was a solder bridge somewhere, but I can't really quite tell where. None of the components here are connected to the traces for this transistor, so it's not really like the traces on this transistor were like shorting to the trace next to it. Don't really understand. Doesn't make much sense. Either way, let's put this transistor back and see whether that continuity comes back. Like, I imagine it won't. It wouldn't really make sense for it to come back. But yeah, it just doesn't really make a lot of sense. Okay, transistor's back. Check continuity. No more continuity. What the hell? The only thing I can think of is that there might have been some absolutely microscopic tiny piece of either solder from the factory or something, or tiny piece of wire strand that was so small it was invisible to the naked eye, that came dislodged just by virtue of the fact that I desoldered this transistor, and it had nothing to do with that transistor or the traces, but it was just in the right area that it got disturbed and is now no longer causing a short between that trace and those components. Okay, so now then, I guess is the moment of truth. We're going to power the amplifier up with the preamplifier board connected and see whether all channels are working as intended with no more nonsense between front left and rear left. So plug that back in, crack that on there like that, yep. There's one, this is going to be gain down low, yep, okay, cool. So, power supply on. So this is currently connected to, the RCA is plugged into front left. So moment of truth then guys, power it up. So we have nice clean signal on front left. Hopefully we don't have anything on rear left. Ready? 3, 2, 1. Oh, there's nothing on rear left anymore. Oh my gosh. Okay. What the hell? Now let's check rear left individually. Rear left, plug that in. Nice clean sine wave on rear left as well. The thing's fixed. Do I know what I did to fix it? Not really. I just freaking... So yeah, it literally must have been an absolutely microscopic solder strand, wire strand, something that was causing a connection between two traces that was invisible to the naked eye, that I just happened to find by removing a component nearby that I wanted to remove to follow a trace on. Whoa! That was a head feck if there ever was one. Bloody hell. Whew. But yeah, Tin Whiskers, Nicholas Williams, absolutely right. Wow. Okay, perseverance pays off. No idea what to charge the customer for that one. 6 new op amps, couple new surface mount resistors, and a lot of troubleshooting, and that's it. Not much component cost. Just a lot of nonsense, a lot of back and forth. That was a good one. That was satisfying. It wasn't good while I was repairing it because I was like, what is this bullshit? Like, how would you even approach a problem like that? Like, I don't think any real sort of like circuit training or like experience in knowing how circuits work could really prepare you for that. Like, that's just a problem solving thing. Like, yeah, that, like, no matter how much you know about circuits and how circuits work, I don't think would have helped you to find that problem there. That was just like a literal track and trace problem solving kind of issue that yeah, no idea. But yeah, guys, right, it's about time for me to go cook some dinner, I think. I'm a bit late on that. So I'm going to go and yeah, lock off the stream now in a minute. I'm going to go cook some dinner, and then this evening I'm going to be filming Boom or Bust. So yeah, won't be seeing you this evening, but I'll be filming for you guys. Boom or Bust, really exciting episode. Hopefully it turns out alright. And I'm going to be retesting the Half Wicked one to make sure nothing's changed, because I'm a bit skeptical, because the two videos definitely look like the demos on the T-line definitely look louder than the demos on the Half Wicked one. So I just want to double check. I want to retest the Half Wicked one, make sure that something hasn't changed about my test setup that I'm unaware of. And then I'll be filming the episode for tomorrow. So Sunday, tomorrow night, new Boom or Bust episode. Yeah, hopefully you enjoyed the stream, guys. I'll catch you in the next one. Have a great evening. See you later.